Hi everyone, this is Naveen from Azure Developer Community. Today I'll be giving a session on Introduction to Service Mesh, Linkerd. So before starting on to the main part, I'll just start off with a quick brief about myself. Currently, I am involved as a senior DevOps consultant in Ops3 Solutions. I've been working in multiple DevOps related projects and Azure being my primary cloud. I am Azure certified. Also, I do multiple open source contributions. So that is pretty much about me. So now without any further ado, let's roll on to our session today about service mesh and Linkerd. So what exactly is service mesh? Today, in this world of microservices, we know we have a lot to, take in our system. We have multiple microservices running. We have a whole bunch of things going on. So we have a lot of microservices, and those microservices have made our life easier. We know that. But when you have a lot of smaller components, the overhead to monitor and manage those microservices is something that comes into our mind. So that is something which we have to take into account whenever we are creating our microservice based architecture. It is very important that we understand the service to service communication, and that is our general perspective. So before microservices, even when we are talking about standard applications, standard architectures, we will definitely require a certain level of visibility on how my services, how my application is communicating with other components. So that is a very crucial part, because at infrastructure level we have a better visibility, because we have a multiple components that are in place in terms of our infrastructure. We have our Prometheus Grafana primarily, for anything and everything that we have to monitor in our infrastructure perspective. But it is not always the infrastructure that I have to be worried about. It is my application as well, which I have to give equal importance. So whenever I'm talking about my application and the components of my application should have that level of visibility, should have that level of monitoring in place, so that I know what exactly is going on in my application, how I will be interacting with my application, how my application is interacting with the other components that it is having in its purview. So that service to service communication is what we enable using Service Mesh. So with the help of this technology, what we are doing is we are enabling that service to service communication. We are getting a better visibility on how my services, how my application components are interacting with each other, how the latency is in between those components, if there is any endpoint which is not responding properly. So a service mesh provides us with that entire visibility. So that is the primary advantage, and the basic concept of introducing service mesh in our infrastructure is. So I'll just quickly start sharing my screen as well. All right. Yeah. So as we just discussed, in our service mesh. So it provides us a better visibility of our application communication, how my application components are interacting with each other. So the primary advantage that it gives us is we do not have to incorporate any specific logic or any specific component in our application as such, because the application's primary focus should be its functionality, not the monitoring and governance is not something that the application should be worried about. So if we incorporate all that logic in my application starts getting bulkier and bulkier. So in order to remove that overhead, in order to remove that burden from our application, we have completely segregated that logic out of our application. So now going in the application as a specific agent, service mesh simply works as a sidecar in our application, which works as a proxy for our application in order to enable that service to service communication. So let me just quickly show you with our little infographics. Alright. So now I'll just show you how the standard service mesh architecture works, or how service mesh fits into our application landscape. So in general, what we have is we have a standard application. I'll just zoom in a bit. Yeah. So this would be my service one. This would be my service two. So now in general what happens is when we talk about service to service communication, my for instance service A directly interacts with my service B, or my second service. Service 1 is directly interacting with service 2. So in this standard paradigm we are enabling a standard or generic communication between one service to the other. Right now we do not have any mechanism which can govern how this communication is working, how effective is this communication, how much time is a request from service 1 taking in order to reach to service 2, and how much time service 2 is taking in order to respond to that particular request. What is the latency between these two services? Are the endpoints which my service 1 is hitting for service 2 healthy or not? So this mechanism with all these features right now we are not having. We do not have this visibility in the standard workflow. Now once we incorporate service mesh in our architecture, things changes slightly. So what we will be having now is, so I'll just make it slightly bigger. Yeah. So now we have introduced service mesh in our infrastructure. So what happens is, as soon as any request comes from service 1 to service 2, it will not directly interact with my service 2. It will first interact with the service mesh, the proxy API, and then it will go to my service 2. Now as soon as it interacts with my service mesh, my proxy, then it starts fetching all these telemetries, all those matrices from my particular service request. And that is the entire gist from where we start getting that entire visibility of my service to service communication, and how my components are interacting with each other, what is the architecture, or what is the workflow of my application looks like. So that is what a service mesh does. So service mesh will give us that complete visibility over our application communication. And one such tool that is introduced and which is right now widely used in the microservice based architecture is Linkerd. So Linkerd is a lightweight service mesh application which works as a sidecar container in all our microservices. And once it is injected as the sidecar container, it will work as the Linkerd proxy, which interacts with all the requests that are coming to my various services in my architecture. Now we can have 20 microservices, we can have 200 microservices. With Linkerd enabled in all those microservices, we will get the complete visibility of the workflow of all the requests that are flowing in my application, and how my various components are interacting with each other. So that is how my service mesh works. And this is Linkerd, which enables all these components to us. So we'll be discussing a bit more about Linkerd, what Linkerd is, what benefits Linkerd provides us, and then we'll be moving on to a short and quick demo where I'll show you a hands-on with. installing Linkerd on my system, and in my cluster I'll enable Linkerd, and then we'll see what sort of visibility we get after enabling Linkerd in our environment. So moving on ahead. So Linkerd, when we talk about Linkerd's architecture, Linkerd is primarily divided into two components. There is a data plane and there is a control plane. Now, first, when we talk about the control plane, what control plane is? Control plane holds all the components of Linkerd. So anything and everything that Linkerd requires for its functionality constitutes its control plane. Control plane is different from the data plane. So control plane usually sits outside my data plane, and control plane will contain all the Linkerd components which Linkerd requires for its proper functionality. Right? The control plane will manage everything, the proxies that are being enabled in my service communication, the TLS encryptions, anything and everything that my Linkerd needs will reside in my control plane. So all the Linkerd components will reside in my control plane. Now we come on to our data plane. Now data plane is something that is completely a rest of the cluster. So in all the applications where we are injecting Linkerd as the proxy, that will constitute my data plane. So all the pods, all the deployments that are Linkerd enabled and that are deployed in my Kubernetes cluster will constitute my entire data plane. So that is my control plane and that is my data plane. Now in our data plane, we will be injecting that Linkerd proxies in our infrastructure and our architecture. So these are the two primary components of our Linkerd. We have the control plane and then we have the data plane. So there are a bunch of advantages that Linkerd provides us. First, it is very lightweight. So it will not use a lot of resources in my infrastructure if I enable it, making it a very efficient tool to work with all our environments and our applications. Plus, it works as the sidecar proxy, so it is not putting any extra stress or any extra load on my application. It is working as a standard sidecar application. It provides us with all the telemetry and all the visibility that we require for our application. When we talk about all the telemetries and all the matrices, that means we will get a complete view of all the requests that are coming into my services, my application components. We'll be able to see the latency of those components. We'll be able to see what are the issues where my requests are slow, where my requests are working fine, where my requests are failing. So all that visibility we will get with Linkerd. So Linkerd provides us with all these amazing features. Also, we can cherry pick these features. It is up to us which feature we want to enable in our Linkerd and which feature we do not want. Linkerd also provides us with something called as mutual TLS. So what mutual TLS is, Linkerd makes sure all the applications that we are having are TLS enabled. So there is a transport layer security enabled in all my microservices from Linkerd, and those certificates are auto rotated by Linkerd itself. So it gives us an additional layer of security at my application level. So that is one of the other advantages that we get from Linkerd. So these are some of the features of Linkerd which we get. So we get all these amazing features, and with these we can get a better and clear view of how my application actually is performing. So it is very useful in terms of monitoring our application performance matrices. So these were some of the advantages of Linkerd and how Linkerd helps us in our microservice based architecture. So now we will be moving on to a short demo where I'll show you what Linkerd does and how it does it, and what all are the components we require in order to enable Linkerd. So what I have right now with me is I have my Kubernetes account I'll be creating. So I have my Azure account, and here I'll be creating one new Kubernetes cluster. All right. So we'll create A new AKS cluster, I'll keep it a simple small cluster. We do not require any zone redundancies since it is just a demo cluster. I will disable auto scaling and I'll keep it a single node cluster. Rest everything will remain the same. So before having Linkerd in your system, you need to have a functional Kubernetes cluster as well. And when we install Linkerd, when we enable Linkerd will also provide us with a web interface. So with that web interface, we'll get the complete dashboard where we can get all these visibility, all these matrices. We'll be seeing the entire chart of how our applications are connected, what is the flow of my application communication, what requests are coming in, what requests are going out, how much time our request is taking. All these visibility we get in that dashboard. Plus, it also provides an integrated Grafana dashboard for all the services for which we have enabled Linkerd. So we'll get the customized matrix dashboard, proper Grafana dashboard for all these services as well. So all these components will be seeing in a short while. So it'll take a few minutes in order to initialize the Kubernetes cluster. All right. Okay. It's almost done. So Linkerd provides us with one more functionality that we'll be seeing, that is a tab functionality. So with the tab functionality, what we can do is we can explicitly check a particular endpoint and see how well it is performing. What is the response time that we are getting on that particular endpoint. So just like this, it provides us with a lot of features which can help us get a better visibility and maintain a better application environment for our microservices. So first we will be having our Kubernetes cluster in place. Once the Kubernetes cluster is all up and running, then we will move on to the Linkerd components. Then we will start off with the Linkerd setup in our cluster. So all the commands that I'll be using for this demo, I'll be sharing all those commands as well in my public repository so that you guys can go around and play with it. And as I just mentioned, Linkerd provides us better observability, better reliability, and better security for our application. So when we talk about observability, as we were just discussing, it provides a bunch of matrices which we can use in order to monitor our applications. And when we talk about reliability, it will know which pod or which container is not working as expected. So it will make sure that not a lot of requests are going onto that unhealthy container or the container which is not responding properly. That is something Linkerd takes care on itself. So we do not have to worry about it. So we get a better performance, a more reliable system. And from security, as we discussed, it will provide mutual TLS. So we'll get TLS on all our Linkerd enabled services. So we ensure that yes, the encryption is in place, the transport layer security is working as expected. So these are few of the other benefits which Linkerd provides us. So in order to install Linkerd, we can simply install it using a curl command. So I already have Linkerd installed, but if you want to install Linkerd, you can simply run a standard curl command. Install sh. So if you execute this command, what it'll do is it'll install Linkerd client on your particular environment. So you can right away run this command and it will install Linkerd client. And once you have the Linkerd client, after that you will be moving forward. So the first step in order to get things done is have the Linkerd installed, and you can use this command. I'll just share it in the meeting group chat also. Just to install Linkerd. All right. And before proceeding to anything, any operation that you want to do with Linkerd, we have to ensure that we have our Kubernetes cluster up and running, because it will performing all its operations on the Kubernetes cluster itself. So we have to ensure our Kubernetes cluster is up and running. Post that, we'll be starting off with all the components and all the operations that we can do with Linkerd. So once you have Linkerd installed with this command, you only have to execute Linkerd version. It will give you the current version of Linkerd that you're having. I'm having Linkerd 2.11. So you might have some other minor upgrade in the version, but that will not make a lot of difference. Most of the functionality will remain the same. So previously Linked's UI, the dashboard that we get was simply from the Linkerd UI command, but now Linkerd has introduced another component called Linkerd Viz, and that Linkerd Viz component is primarily used in order to get all those UI components, the dashboard and everything in place. All right, it takes a lot of time. All right, so let's just give it a few minutes to install. It's almost done. It is just stuck at the last step. Once we have it, we'll move on to our next step for the demo. So for this particular demo, I'll be using a dummy application called Emoji Auto. So that is a simple and a basic application. Fantastic. We have the cluster ready as well. So now we have our cluster ready. So I'll just quickly connect on with my cluster now. I need to log in again. All right, we should be in now. Okay. So now let's quickly connect with our Kubernetes cluster. Okay. So I show you my current cluster. I'll just zoom in it. So first we'll have a look at the namespaces. We have the standard namespaces, nothing fancy here. In our nodes, we'll be having a single node only because it was a single node cluster. So that is it. We have the basic bare minimum cluster right now with us. So the first thing that we have to do before installing Linkerd is to do a pre-flight check. What that pre-flight check will do is it will check all the components in our Kubernetes cluster, all the required components are present or not, if there are any dependencies which is not able to find. So it will do sort of a pre-flight check, a sanity check before we proceed into anything else. So to do that, what we do is we do Linkerd check pre. So as you can see, it will perform all the sanity validations on our Kubernetes cluster. It will check the Kubernetes API version, Kubernetes version, and everything is up to date or not. So you can see it checked our Kubernetes APIs, checked the version, it checked the pre-Kubernetes setup. We have everything. It can create everything, because once we install Linkerd on our Kubernetes cluster, it will be deploying a lot of resources. It will be deploying the deployment service accounts and everything. So it has to validate that it is able to create all those services, because when we are talking about production grade clusters, there would be RBACs in place, there would be policies in place, so that everybody cannot perform all the operations. So if you cannot create the resources, then you will get the failures on those particular steps. So it is a good practice to perform the pre-flight check. Now we have everything up and running, everything is fine. So this means we can proceed ahead with the installation of our Linkerd in the cluster now. So in order to install Linkerd, we'll use the Linkerd install command. Linkerd install. Now we'll pipe it to apply. So what it will do is it will automatically get all those manifests and it will start applying those components. Now you can see it is creating a bunch of resources. It is creating cluster roles, it is creating service accounts, it is creating services, it is creating validation webhooks, it is creating roles, it is creating CRDs. So a bunch of resources it is creating. So that is why the pre-flight check is important, so that we do not get any sort of failures while installing Linkerd in our system. So we have to ensure that we are able to create all the resources in order to have Linkerd up and running. So once the installation is done, then we can check all the components are installed properly or not, and that is something which we can do with the command linkerd check. So what linkerd check will do is linkerd check will see everything, all the components that we installed with the previous command of linkerd installed are installed as expected and there are no issues there. So as you can see, it is validating all the components which were deployed in this previous step. So it is checking all the Linkerd components, all the configs, all the identities, all the services, all the webhooks. So everything it is validating and everything is fine. So we got a successful installation of our Linkerd. Now what we have to do is we require that UI from which we were talking about, where we'll be getting that visibility of our application. So as I mentioned, now Linkerd has installed, introduced the component Linkerd Viz. So if I show you the namespaces, now we should see something added there. So you can see we have Linkerd now. So now what we have to do is, just with Linkerd we will not be able to see the UI. So in order to get that UI, in order to get that dashboard, we will need to install Linkerd Viz in our cluster. So what we will do is we will use Linkerd Viz, Linkerd install. So what it will do is it will simply install Linkerd Viz on our cluster, which will help us get that dashboard up and running so that we can see all the matrices in our application. So I'll simply install Linkerd Viz in my cluster now. So as you can see, it is creating all the Linkerd Viz resources now. So we are getting all the roles binding services for Linkerd Viz, and once this is done, this installation is done, then we'll be having one more additional namespace added in our cluster. Right now we were only having a single namespace by the name Linkerd. Now we'll see one more namespace created by the name Linkerd Viz, and that namespace will be responsible for all our dashboarding and stuff. So you can see we have the Linkerd Viz namespace also created now. Now, once we have Linkerd Viz installed, what we have to do is we have to launch the dashboard. And in order to launch that dashboard, what we do is we execute the Linkerd Viz command. Linkerd Viz dashboard. So what it will do is it will deploy the dashboard and we will be able to get a visual of our entire cluster and all the application components which are deployed there. All right. So the dashboard is opening up. So now you can see this is how our Linkerd dashboard looks like. So you can see on the left menu blade, we have everything. We have namespace. If I click on control plane, you'll see the control plane. This is the control plane. You will see what all it is having here in the control plane. So we'll go to namespaces. In the namespaces, we can see we have all these namespaces right now. We have default, the standard namespaces and the Linkerd and Linkerd Viz. Now you can see in the meshed section, right now we do not have anything meshed in the cube system. However, on the Linkerd namespace, everything is meshed. Everything that is deployed is meshed right now. And that's why we are able to see the success rate, the request per second, the latencies. So this is a basic view. Now you can see we get a really decent amount of visibility on how my application is performing, and it gives us a bunch of matrices with which we can identify what is not going right in my application. So you can see we have the TCP matrices, we have all the components here also in the workload, so we can specifically filter out what we have. We can go to deployments, we can daemon sets, we can see jobs, anything and everything. And in the tools, as I mentioned, we have the tab functionality also. So now we do not have the application as of now, which is meshed. So we can see we do not have anything here apart from the standard deployments. And in the kube system namespace, we do not have Linkerd injected, because of which all the components in the kube system namespace right now are not meshed. So Linkerd is not monitoring those components. So that's why we cannot see any matrices for kube system namespace. And it also provides the Grafana dashboard, which I talked about. So here you can see the link to a Grafana dashboard from where we can see the live matrices. So if I just click on it, I'll show you. So here you can see with Linkerd as its data source, it is fetching all these matrices for all the components which are meshed in our Linkerd. So we can see the success rates, the request volumes, the deployment monitored. It is deploying it is monitoring three deployments which are currently deployed in the Linkerd namespace. So we will get a detailed dashboard here. So that's a pretty neat stuff. So now what we will be doing is, now we will be having our new application, our application deployed in the cluster, with which we will see what all matrices we are getting, so that we can get a better understanding. So what we'll do is, it will be a simple curl command. That is emoji auto. So with this, you can see this is that emoji auto application which I was talking about. So here we can see all the manifests that would be deployed. So it will be having a deployment, it will be having a service, it will be having its config map. You can see the deployment here. So now what we will be doing is, we will simply adding it into our cluster. So we will simply apply it in the cluster. So you can see first it has created the emoji auto namespace, it has created the service accounts, it has created the service, the deployment. Now we have our application deployed in our cluster. So now if I show you the namespaces first, so you can see the emoji auto namespaces created. So now let's see what do we have in this namespace. So you can see we have the pods, we have the service, we have the deployment and the replica set. Alright, there would be one change. The web service has to be of type load balancer. Right now it's cluster IP, so because of which it would not be exposed on the service. So what I'll do is I'll quickly update the service. So, but before doing that, let me just show you one more thing. So here you can see as soon as we deployed our microservice, as soon as we deployed our application in the cluster, the service was available now. Now we can see we have the namespace of emoji photo. Now if I click on emoji photo, we can see right now nothing is being meshed, because of which it is not able to monitor anything. So we do not have Linkerd proxy injected in this emoji photo application, because of which no matrices are showing up. However, it is able to pick all the components which are deployed, but we cannot see the mapping and we cannot see the requests and all the matrices which we are supposed to see. So in order to do that, we need to inject Linkerd in our application. And in order to do that, what we do is we execute the command Linkerd inject. So in the same command, the Linkerd emoji photo will add one more pipe, Linkerd inject. So what it will do is it will inject that Linkerd proxy in our application, and then it will redeploy the entire application. And when we say it will inject Linkerd, so what it will do is it will simply add one annotation in the deployment. So that is the only thing it does. So now let's see. Now as you can see, and the namespace it will not be deploying, so that's why it is skipping. Now here if you see in the deployment it is injected. So now the Linkerd component, our Linkerd proxy is injected in our components, in our deployments and in our services. So now if we see the entire view has changed now. So now we have started getting all the matrices and all the telemetries, and that is the beauty of Linkerd. With minimalistic efforts, with minimalistic configurations, we are able to inject our proxy server, our Linkerd proxy into our application, and now we are able to get all the real-time matrices for all our applications. So you can see all the deployments, and we can see in the voting there is not the highest success rate. So we can very well go inside any component which we see is not responding as it should have, and you see we will get the entire workflow chart of how this application is working. The web and our Prometheus is interacting with the voting service. So you can see here. So this, see, this is the entire map. So this is the beauty of Linkerd. It will not just give us the matrices, it will also give us that visual of how my application components are connected with each other, from where the request is coming, from where the request is going. So that entire visual we will get on a single place, and it is very, very helpful in the production environments in order to debug any application related issues, any application latency related issues. So it is very helpful in order to debug all those components. So as you can see, we have all the components here. So I just go back in the emoji photo. So now you can see we have web. Web is interacting with voting, emoji, and votebot. What is the votebot is doing? This votebot is randomly throwing requests at the web, which is creating that requests on our application. So this bot is nothing but this bot is generating that dummy requests on our application, because of which we are seeing traffic here. So if we click on web, because web is our primary component, from web we can see it is connected to all other components. So we can see in votebot the success rate is not above 80%, above 90%, and in the voting we can see the success rate is the least. So this view helps us to identify where the issues actually are in the application. And here also we will see all the endpoints which are getting hit. So let me see if I can. All right, so let me just edit this service once. All right, type, I'll change the type from cluster IP to load balancer. Okay, so now our external IP is pending for web service. We'll be creating the load balancer, and once the load balancer is created, we'll get the public IP. Then we'll try to access the application if it is accessible or not. All right, we have a public IP. Let's check if it is accessible. Because ideally, it should have automatically created the web service of type load balancer. However, it didn't. So this is our dummy application, as you can see. So what it'll do is it'll simply we can click any of the emoji and constantly read it. And here the vote bot that we talked about, that vote bot is simply generating random dummy requests on random emojis out of this list, from where we'll see the leaderboard. For instance, let's say I select this ghost emoji. All right, now I'll view the leaderboard. Here you can see. So all these numbers which you are seeing are generated by the vote bot. The vote bot is simply generating request on these dummy emojis, which is creating all these requests. So now let's see, we'll click donut. So this is the problem endpoint here. So now we can see when I clicked on donut, I did not receive any specific response which I should have, like we did in our previous emoji. So that means there is one issue here. When I clicked on donut, we get 404. That means it does not exist. So however, I know that there is a issue here. If I click it again, so I know there is a issue on this donut endpoint. Now I want to, let's see if we are getting that visibility here or not. So now see, we have the vote bot. Vote bot is going to web. From web we are getting to voting, and the least percentage we are seeing is in voting. So let's go on to voting. So here let's go on to deploy voting. So we are getting all the endpoints here. These are nothing but the emojis for which we are getting the requests. So till now for these endpoints we have 100% success rate. So we should have the, let me see if I can get donut and we get donut, bacon, voting turkey, select again, see if we can. So on the voting matrix we have the least percentage. See, now we can see on the vote donut endpoint the success rate is 0%. Rest all the endpoints seems to be working fine, and that is where the issue exists. So now it gives us that visibility which explicit endpoint is failing. So I can also see, I cannot just tell the developer that okay, the voting functionality here is giving 404. We can explicitly tell them that this is the endpoint which you need to check. This is your explicit endpoint which is failing. So we can do the tap functionality which I talked about. So what this tap functionality does is the tap functionality will simply put requests. It will try to access that particular endpoint and it will see what response we are getting. So I'll start this. Let's start it. If we get anything here, see. So from here, we can explicitly start our tapping functionality and we can see what is happening, or, how much latency we are getting, what response are we getting. So that way we can get the correct endpoints also. And with this endpoint, we can share this information with the developers so that they can also start directly working on the unknown endpoint, the endpoint which is faulty. So this is how Linkerd provides us with a whole lot of better visibility onto our applications and the endpoints. So we'll just simply stop it. So now you can see all the benefits that we are getting from Linkerd. So not just we are getting the request success rate or the latency, we are getting the entire application workflow chart along with all the endpoints at which requests are going and what is the response on those endpoints as well. So we are getting a detailed view of our application workflow. And we also talked about the dashboard, right? So I'll just show you the dashboard for this namespace since it has the application. So now you can see. So let's say we know that voting is having issues. So we'll open the voting dashboard. So here we can see the success rate, the request volume, all right, how the success rate is going up and down, what is the request volume. So as you can see, we have all these components now. So we have a great visibility of the application, not in just in terms of our matrices or our network component, but in terms of dashboarding and monitoring as well. So all these visibility we are getting with just a single lightweight component, and that is the beauty of Linkerd which it provides us. So with the minimalistic efforts, now we are able to completely visualize our application workflow and how the application is performing. Now we can right away go to the developer, we can provide them the endpoints. Okay, these endpoints are not working fine, so you need to have a look into it. And this is how we get that great visibility here. So we can see the number of connections also here. If you see, we have 11 connections right now which are in our emoji photo application. So all these matrices we get from a simple Linkerd deployment, and this is the best advantage that we get. And that service chart I showed you, which we also get from Linkerd. Now we clearly know from where the request is coming and from where the request is going. From voter bot, the request is coming to the web, and from web, it is going to emoji and voting. So we get that mapping also, how my different components are mapped with each other. So this is another advantage which we get. And not just from the dashboard, we can get all the components from our CLI also. So let's say if I want to check the stats from my CLI also. So we can do it from linkerd stat command. And then the component for which I want to check the stats for. So as you can see, since linkerd commands are now slowly getting deprecated, linkerd viz is what is now commonly being used. So now here you can see the complete detail of all my deployments in the emoji voto namespace. We have emoji, votebot, voting, and web. All these four deployments, all of the four deployments are meshed. We can also see the success rate for emoji and voting bot. The success rate is 100%. For voting, it is 84. Web, it is 91. We can see the request per seconds. We can see the different latency matrices, P50, P95, P99 latencies. We can see the TCP connection count as well. So all these information we can get right away from the CLI as well. So this is the advantage that we are getting from Linkerd. And now we talked about the security as well, the security component, that it also provides or enables mutual TLS in our application. Now we'll see that certificate or the proof that okay, it has enabled that TLS, that mutual TLS on my application. So for that, what we will do is we will use the command linkerd edges. So now you can see all the components that we have. It has deployed the VoteBot, the web component, the Prometheus component. All of these components are secured. So these are all mutually TLS enabled. And we can verify this by doing a tap command also. Linkerd tap. So in these logs, you can clearly see that the TLS parameter is enabled. So all the requests that are flowing in our application from application to application are encrypted, are TLS enabled. So that is the advantage. We are not getting TLS only at the web level. We are also now getting TLS at our internal microservice layer as well. So from the standard, TLS or certificates, we can enable SSL or TLS in our web applications. But now with Linkerd in the picture, we have TLS enabled in our microservices as well. So all the internal communication that is happening, that is also TLS enabled. It is not a simple plain communication which is happening. We have a TLS enabled communication. So these are some of the benefits, means there is a lot that you can do. So right now, as you saw, we manually injected Linkerd in our application. So in production environment, we probably do not want to do a manual inject. So for that, Linkerd also provides us with the functionality called auto inject. With auto inject, what we do is whenever a new deployment comes into the picture in our cluster, it is automatically injected with Linkerd proxy. So as soon as you deploy the application, Linkerd will also inject the Linkerd proxy sidecar into that application. So we do not have to worry about manually injecting Linkerd in every application, because in production or in real life projects, it becomes a tedious task. So that is the beauty of Linkerd. And these were some of the features which we went through in this demo. This was our introductory session. And I hope with this session you are able to understand what Service Mesh is, how Service Mesh works, what functionality or what benefits Service Mesh provides us, what are the functionality of Linkerd, what advantages it is bringing onto the table for us in terms of a microservice based architecture, and how easy it is to maintain it, and how well it is providing us with all the visibility and matrices for our application and application service to service communication. So this would be it for this session, guys. I hope you guys enjoyed it and you got something new to learn. So until next time, see you guys. Thank you so much. Bye bye.